Hi there, folks. So we're going to talk a little bit about how to account for the energy of a fatty acid, and we're going to talk about different forms of it. So I'm going to switch back to a pretty basic one, and we'll talk. So here I would just have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 carbon fatty acid, or acetyl-CoA. And we're going to be breaking this into acetyl-CoAs. So if you want to review on that, you can look at the beta oxidation page. But we're going to be breaking this into two. 1, 2, 3, 4, 5, 6, 7 breaks. 7 breaks into 8 acetyl-CoAs. So we're doing 7 rounds of beta oxidation to break this up into 8 acetyl-CoAs. So why is there 7 rounds to get 8? Well, when you get down to 4, the last break gets you 2 acetyl-CoAs. You don't have to go from 2 to 0. It doesn't go 16, 14, 12, 10, 8, 6, 4, 2, 0. It just stops at the 4 and goes into 2 2s. So there's n-1 acetyl-CoAs. So if you wanted to figure out how many rounds you would need, if n is your carbons in your in your fatty acid, n over 2 is going to be the amount of acetyl-CoAs, minus 1 is equal to the number of rounds. So here we have 16, n over 2 of that is going to be 8 acetyl-CoAs minus 1 is going to be 7 rounds. And if you remember what each round gets you, it gets you 1 FADH2, 1 NADH, and 1 acetyl-CoA. So that's going to be worth 2 ATP by theoretical yields, 3 ATP for the NADH, and acetyl-CoA gets you 12 ATP going through the Krebs cycle. Remember, there's 3 NADH from Krebs, 1 FADH2, and 1 GTP. That is 12 ATP. So we end up with a net total of 17 ATP per round. Okay. So we have 7 rounds times 17 ATP per round. What is that going to be? 7 times 17 is 119 ATP. But remember the last one. So we have 119 ATP from the 7 rounds. Now remember we also have an acetyl-CoA that came from the last step, which is worth an additional 12 ATP. So we're at 131 ATP. But it costs 2 ATP to put the CoA onto our acyl group. The acetyl-CoA synthetase does an ATP to AMP, which costs 2 ATP because you have to take ATP plus AMP to get to 2 ATP that can be recharged. So we have to take 2 off, and so we end up with a grand total of 129 ATP. So keep that in mind, some of the places we lose stuff. The charging is always going to be a minus 2. So for everything, you'll have a minus 2 on it at the very end. Okay, so I figured out my rounds, my 17 ATP per round, and then the extra acetyl-CoA at the end. Alright, so here we have a odd chain fatty acid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 carbons. So I'm going to chunk this up into 2s. 1, 2, 3, 4, 5, 6. 6 rounds times 17 ATP. It's 102. Okay, now remember we have this 3 carbon piece left over, and a 3 carbon piece is worth 5. And that's the succinyl-CoA. And if you don't remember how that works, check out the YouTube video about odd chain fatty acids. It's 117 ATP minus the 2 to make this, so we end up at 115 ATP. Okay, so just going from 16 to 15, we lost 14 ATP. And remember, the reason for that is that we have a succinyl-CoA instead of the extra acetyl-CoA, and we have one fewer rounds of beta oxidation. So we're getting a lot lower yield from an odd chain than a even one carbon longer even chain. Okay, so now we have an even chain. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is a 16-1. So now we have a unit of unsaturation in the tail. Okay, so I'm going to start doing this the right way. I'm just going to start chunking it up, and what we're going to end up with here is going to be something like that. We're going to have already an alpha beta unit of unsaturation, which means we lose one FADH2 because we don't have to make that. Okay, so I'm just going to continue going about. You just skip over that first acyl-CoA dehydrogenase step on that round of beta oxidation. You have 1, 2, 3, 4, 5, 6, 7 rounds times 17 ATP. That's 119 plus acetyl-CoA. That is 131 minus 2 from the unit of unsaturation minus 2 from acyl-CoA synthetase. So with that extra unit of unsaturation, we lose another 2. So 16-0 was 129. The 16-1 is going to be 127 because we lose that first FADH2 we get from acyl-CoA dehydrogenase. All right, now here we're going to kick it up a notch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is a 13-1. So I'm going to start chunking it. Okay. So again, you see we're going to have a 3 carbon at the end. We're also going to end up with a unit of unsaturation, but it's going to look like this. Now that doesn't look like our normal NADH, and so we need to use an isomerase. That's free. It doesn't change our yield, but it does get it into the right place. We're still going to lose that FADH2. So we're still minus 2 ATP. So here we have 1, 2, 3, 4, 5 rounds times 17 ATP. That is 85 ATP. Plus 5 from succinyl-CoA, from the 3 carbon at the end, 90 ATP. Minus 2 from the unsaturation, 88. Minus 2 from acyl-CoA, 86. 86 from that guy. Okay. So again, we did our normal rounds. Then we had to look at the odd numbered piece at the end. That gets us 5. We had 2 from the unit of unsaturation anywhere in the chain. We get that minus 2. And 2 from starting with acyl-CoA. So 86 for this 13-1. And here is a conjugated polyunsaturated. So this is a little more difficult. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is a 14-2. Conjugated, which means that the double bond, it goes double bond, single bond, double bond. And that takes a little bit of extra work. As you can see, we're going to lose the 2 FADH2s because those are already there. It might look like that. In this case, since they're conjugated, we're going to have a little bit more complex of a solution. So I'm just going to chunk this up. It's 1, 2, 3, 4, 5, 6 rounds. If they're conjugated, we actually lose an FADH2 and an NADPH. So that's minus 5. Okay. That reason for that is that we have to essentially reduce one of these double bonds to single bonds using an ADPH, which loses us 3 ATP. So we'll just look at this times 17. 102 minus 5 from the conjugated is 98, 97. and 97 minus the 2 for the acyl-CoA. 95. Okay, so that's going to give us our final yield for the conjugated polyunsaturated amino acid. So the 5 come from the fact that the conjugated causes not only an ADPH but also an FADH2, so it gets worse with the conjugation. So we end up losing an extra ATP.